So this is going to be a video on the 9-2 notes, which are constructions with circles. So first of all, I want to kind of read through this first part of the notes, which talks about how we construct perpendicular bisectors of segments. So typically we would place the compass on one end of the line, and then we'd set the compass width to approximately 2/3 of the line's length. And obviously the actual length doesn't matter. And then without changing the compass width, we draw an arc above and below the line. And then we'd put it to the other endpoint and do the same thing. Draw an arc above and below the line. And then where those two arcs intersect, we would use a straight edge and draw a line between those two things, and that would be where the line was bisected, and this would be a perpendicular bisector. So I want to kind of bring to your attention that we're going to do two different types of constructions today with tangents. We're going to do one where we draw a circle, and we're going to do another one where we just do a perpendicular bisector. Now, both of them require a perpendicular bisector, but we're going to talk through the process of this with both of these. So the first construction we're going to do is constructing two tangents to a circle from an external point. It says draw a line from the center of the circle to the external point, so that's the first thing we're going to do. Then it says construct the midpoint of the line from the center to the external point. So what we're going to do is we're going to do this perpendicular bisector thing, because that's how we are going to determine where the midpoint is. So we're going to draw an arc up there and an arc down here, and without moving our slider, we're going to put our dot over here, and we're going to do the same thing. Again, we're going to do an arc above and an arc below. Now where those two arcs intersect is going to be the midpoint of this line. And frankly, it's also a perpendicular bisector. It's both. So in these instructions on number 3, it says measure the distance between the midpoint and one endpoint. So we're going to measure this distance here. I'm going to put it out here. Measure this distance right here between the midpoint and that external point is what I'm going to do. Then it says draw a circle using the midpoint as the center and the measurement so we're basically going to draw a circle with this. So we're going to draw it through this, from the midpoint through this point out here. I'm going to draw a circle all the way around. Sorry if my hands are covering it, it's just kind of hard. So that is our circle that we drew, that is has a radius based on what the midpoint of this whole segment was. We're going to mark the intersection of the two circles, this point here and this point here, which are the intersection of the two circles. And these are the points of tangency for the two tangent lines. So what we're going to do now is draw our two tangent lines. So from this external point to this tangent point, we're going to draw this line. And from this external point down here, to that tangent point down there, sorry, we're going to draw the other one. So that's one way of constructing two tangents from the same point, external point. The other set of constructions says draw a straight line between the center again and the given external point. We're going to do that. And this time it says find the midpoint of this line by constructing lines perpendicular bisector. We're going to do the same thing we did last time. Again, we got to go a little bit more than halfway, like our instructions said before, about 2/3. So mark up there, mark down here, and then we're going to do the same thing over here from this point. Mark down here, mark up here, and that's our perpendicular bisector. And this time we're actually going to draw this line through here. So it says place the compass on the midpoint just as constructed and set its width to the center of circle. And then without changing the width, draw an arc across the circle in the two possible places. These are the contact points with the circle for the tangents. So So we place this on the midpoint we just constructed, and we set the width to the center of the circle. It says without changing the width, draw an arc across the circle in the two possible places. So basically we're going to lift this up here, and we're going to mark up here where it crosses, and we're also going to pull it down here and do the same thing. Mark it down here. These now are our points of intersection for where our tangents are going to touch the circle. So we're going to again draw our tangents from out here and our tangent from out here. And those are the two tangents from the same point external to the circle. And just to cycle you back to what we did in 9.1, these two tangents, this tangent here and this tangent here, are congruent because they come from the same external point. So the next construction that we're going to do is a circle circumscribed about a triangle. The perpendicular bisectors, sorry about that, of the sides of a triangle intersect at a point called the circumcenter. So using the circumcenter as a center of the length of the and the length from the circumcenter to a vertex of the radius, a circle can be drawn. So thus the segments from the circumcenter to the vertices are congruent because they are radii of the circle. So what I need you guys to see here is that on this side we have done a perpendicular bisector here, and that means that we have cut this side in half. Here, same thing, we have cut these two sides, or this side, into two equal parts, bisected it with a perpendicular bisector, and same thing here. So when we do this all three times, the point of intersection of these three perpendicular bisectors is the center of this circle, and we call this the circumcenter. And when we do that, and then we draw from the vertices of this triangle to the center of the circle, from the vertice here to the center and the vertices to the center here, those three segments are the same length. I want to show you something else here. So when we're talking about the location of a circumcenter, it really depends on the type of triangle it is. In an acute triangle, which is one like this, where all three angles are less than 90 degrees, the circumcenter is inside the triangle. In an obtuse triangle, if you notice this is an obtuse triangle where that angle is greater than 90 degrees, then the circumcenter could be outside the circle. And when on a right triangle, that would mean that this angle down here would be a right angle. That circumcenter would be on the hypotenuse. So we're going to do this construction next because it is going to use perpendicular bisectors, and we've already gone over that concept. So one of the things you need to understand is when we create these perpendicular bisectors, again, we're going to go to the end point here, and we're going to put an arc up here above, somewhere up here, and somewhere below here on the line. We're going to pick this up. Again, remember, we're going more than halfway. We're going to, again, cross the arc down here, cross the arc up here. And when we do that, that's going to enable us to find where the perpendicular bisector is of the side AC. So I'm going to go ahead and draw this perpendicular bisector. So that means that that's perpendicular, and this side are congruent. Then we're going to do another one over here. So I'm going to do B. Now I do want to tell you that you really only have to do two of these sides. So once we find the point of intersection of these two, then we're good to go. So again, we're going to go up here and over here to find where these two arcs cross. We're going to put one up here and one below the line. I'm going to pick this up, put it over here on the other side, create another arc up here above and below. And again, we found another perpendicular bisector of another side, so we're going to go ahead and draw that perpendicular bisector. And here again, that's perpendicular, and this is congruent to this. Now, where these two perpendicular bisectors intersect is where that center is going to be. So that's going to be that point right there. So now we're going to place this bullseye on that point of intersection we made. And if you'll notice here, when I start moving my compass around, it is actually going to intersect at all those vertices of this triangle. So I'm going to go ahead and draw this circle. Maybe if I can get this all the way around like this. And that's how we draw a circumscribed circle around a triangle. And again, if you recall, I could keep drawing these, but one of the things that I want to point out here is when we do this, that once again, that if I were to draw a line from this vertices to the center, from this vertices up here to the center, and from this vertices over here to the center, these are just radii, and thus all these radii are congruent. So the third construction we're going to do is a circle inscribed in a triangle. This has to do with angle bisectors of a triangle that intersect at a point that we call the incenter. And in this case, the three radii will be perpendicular to the sides of the triangle, and those three are congruent. So here, again, if we bisect this angle here with an angle bisector, that means these two parts are congruent. That would be one angle bisector. Then if we bisect angle B, another angle bisector, bisect angle C, third angle bisector. Where these three intersect, we call that the incenter. And then if we were to draw perpendiculars from those sides, those would be the same length. And again, when we draw this, we're going to find the circle that's inscribed inside that triangle. So the first thing I want to do is remind you guys on how we construct angle bisectors. So we place the compass on the vertex of the angle, we stretch the compass any length that will stay on the angle, and we swing the arc so the pencil crosses both sides of the rays, and then what we're going to do is place the compass on one of those new intersection points, put an arc above it, put it on the other intersection point, put an arc above it, and then we're going to use that point of intersection of those two arcs to find where the angles bisected. So let's go ahead and do this construction now. Okay, so sorry about that. So okay, so we're going to bisect these angles. So I'm going to bisect angle A here. So we're going to draw an arc across the two sides of the angle, and then we're going to use that arc to draw two more arcs out here that are going to enable us then to find the point of intersection of these two arcs and thus find where the angle is bisected. So here we go, we're bisecting angle A. Not perfect, but okay. And I'm going to actually extend this out a little bit further just in case I need to see where it intersects the other one. So now we're going to go ahead and do this angle B up here. So we're going to do the same thing we just did, same process again. We're going to create an arc that goes across both sides of the angle, and we're going to use again those 2 points of intersection to draw two more points of intersection. This then will allow us to bisect angle B. So we're going to bisect angle B right here. Now, where those 2 points intersected, again, we would have bisected this angle up here. So this point of intersection right here is what we call the incenter. Now what we need to do is we need to basically find a perpendicular to the side through a point that's not on the line. So that's what we're going to do next. So I'm going to do it to this side over here. So when I do that, I'm going to actually create an arc that goes across both sides of AC, or across 2 points on AC. And then I'm going to pull this down here, and I'm going to find two more points of intersection down here from those. So I got that one. Here's another one. So we're trying to find a perpendicular now from that side. So I'm going to draw this in a different color because it's not a bisector, but that is going to be one of our radii of our circle. So now let's go ahead and measure this radii. And what it should do when it's all said and done is we should be able to go around here, and it should be creating a point of intersection around the circle that is the circle that we're trying to create that's inside the triangle. So Let me go ahead and move this up just a little bit. Let's see if I did okay on this one. Not too bad. So that is our circle. Not perfect, but close enough.